Copy. Mhm. Oh yeah. Yeah, I'm stepping forward. It's just taking a bit of time. It's at 0.2 knots right now. Oh, was that Sam on the crane? Nice. No wonder she was in a hurry to get out of here. She was... Copy that, tether in the water. Copy that, Argus going down.
This is an audio slate for dive H18367. UTC time is 19:13:44 on my mark. Mark.
Are both the mesos on? All right, we'll start this thing up. Playback, that's the wrong button. Run. Ready for control. Copy that. Copy. Sonars look good. What's that ball tucked in up there next to the craft? That ball tucked in up.
Check, check. So do we have Di and Lisa with us again?
Yes, Di's here,
Hi, Di.
and Lisa's on the chat. Lisa's on the chat and with us as well, but she's going to be leaving at 12:30 for the call, the
Copy
check-in
that.
call, and then she'll be back with us. And this is Stephen, right? Is it Stephen or
Yep.
Steve? Oh, okay. Either or.
Either or. I don't usually register the difference.
So for those that might be tuning in, you're looking at a view from the ROV, the remotely operated vehicle Hercules, and we've just launched and are headed to 900 meters. We just passed the 250 meter mark. We're headed to 900 meters at a target just to the north of a seafloor bank called the Piggy Bank. And we're in the Channel Islands National Marine Sanctuary. And the ROV pilots are testing the operation of the ROV as we descend.
Di, you logged in as Science C or Science 3C, is that right?
Yeah, I think I'm 3C or am I 3B?
Oh, you're
Do you
3B.
show
You're
both?
you're 3B.
Okay. Can you hear me okay?
That's a little better. You were a little low again.
Okay, all right. It's daytime, so I can speak louder.
All right.
Is there a typical descent rate that you guys know of, or does it vary? I imagine it varies if there's current and such, but
No, no, I'm not doing that anymore. Yeah, typically it depends on uh, how light or heavy Hercules is for ascent or descent. I think you were asking about the velocity.
yeah.
So sometimes we can plan, we're going about 25 meters a minute down. Usually we plan on about 20 down and then plan on 15 up.
Got it.
But often we make a bit faster than both of those. Very rarely will we be slower on the way up than 15. But it has happened if we're heavy and don't have enough weights to drop. We picked up a lot of rocks.
So Lisa, my science partner on this first shift of the dive, has just left to be on the call, the 12:30 check-in call, and then she'll be back with us. And
Great.
she's going to get some clarification on the habitat grid. I'm going to call it a grid. We've been sort of interchangeably using the terms 3D mosaic and habitat mosaic and so on. And so she's going to get a little more clarification on that during the call. Which will be good. But I think we did a great job last night. and the outcome's going to be really neat.
I hope so. We haven't processed any of the pictures yet.
It's another objective of this dive. And the first objective is going to be, so there's been a lot of, there's been a mapping initiative, seafloor mapping initiative all along the West Coast, but in particular in the Southern California Bight where we are, to map areas of the seafloor that lacked high resolution bathymetry data. And so this area that we're going to be diving on has, I'm not sure when the data was acquired because there's been a lot of mapping work going on, and it may have been acquired by the Nautilus. I'm not sure.
It was indeed.
But we're.
In 2018.
It was, okay.
Yep.
2018, yep, super. And so one of the purposes or objectives of this dive is to dive in areas and then ground truth, what's being shown by the data. So there's backscatter data that results from this mapping work that indicates areas of hard substrata and soft substrata. And we're interested in finding the hard substrata in particular, because that's where a lot of corals and sponges and fishes reside. So that's gonna be one of the objectives of the dive, is to validate, verify the backscatter data. And we're going to be looking for hard substrate. And then when we come upon deep sea corals and sponge habitats, we'll be doing some transects, quantitative transects. And it looks like, I'm looking at the objectives in the dive plan, I think another photo mosaic of habitat is also on the list if we come across something good. And the purpose of these photo mosaics is to get high resolution images of a 10 by 10 meter square of habitat, and then be able in the future to return to that habitat to note changes in the composition and sizes of corals, sponges, and so forth. And toward the end of yesterday's dive, which started yesterday, ended early this morning, toward the end of the dive, they encountered quite a bit of derelict fishing gear on the footprint bank and had to end the dive early. And there's a question in the chat about whether that fishing gear is old or coming in from other areas or so forth. And the answer is that all the gear that Tom says, all the gear that was seen was really old and had sponges and anemones growing on it, which indicates it's been there for quite a while. But it's a hazard to the ROV and the work we're doing. We don't want to get the ROV tangled in that. So the crew's being very careful to avoid that sort of hazard.
And we brought an extra knife.
Oh, you brought an extra one. So how many total do you have?
Well, now we have 3. This one is a quick draw.
A quick draw.
Yeah. Emergency use.
So we've got, they're showing a knife, and that is, they've got 3 total now on the ROV to cut lines should we encounter them. But we try to see them ahead of time so we don't get entangled. Right, guys?
Yeah.
And gals?
If we can see them, then we'll try to avoid it.
Yeah. We just crossed the 500-meter mark, and again, we're headed to 900 meters.
If you take a look at HiPAC, I've just pulled up for this first stretch of the dive. We've got a slope map. Here's the bathymetry I'm pulling up right now. We're deep and we're going up slope to a higher point. The slope on the way, probably not too intense, and backscatter behind is pretty varying, so I'm presuming we're going to try to hit those lighter spots on the way.
Yeah, I see that. Thanks for bringing that up. And then we're going to be going down slope a bit, right, towards EB.
EB is all upslope.
Oh, it's all upslope that way. Okay,
Yeah, sorry,
we're
I'll
zoomed
pull up.
in farther than
There's the bathy right
that's
there.
okay.
That's a bit easier to see. We're just going up.
Yeah, yeah. Okay. So, and these contour lines are, what's the interval for them?
They are 10-meter vertical separations, so 10 meters
Okay.
rise.
So we've got a pretty good slope, it looks like, would you say?
Let's see, it'll be 10 meters over, sorry, let me turn that back on. 10 meters over 30 meters, so not terribly steep.
Not real steep.
Yeah.
It's really cool how you guys can land so close to the planned dive target. I remember back to the days when I was fortunate to be able to dive in the Delta submersible, the manned submersible, which isn't tethered.
Mm-hmm.
And sometimes we would drift quite a ways from the intended target and then have to navigate our way back to where we wanted to land if the currents were not working in our favor.
18-degree slope.
18-degree slope, roger.
Oh, okay, so that's pretty low, not very steep.
So we can take a look here now while we're on the descent, but what I'm looking at as far as getting up to point EB, as far as backscatter goes and the slope, perhaps we head kind of directly up slope in this direction, get all this, the steeper slope that we can, maybe lateral over on this flatter bit, and then try to head up on the steeper bit there towards EB because the backscatter looks like we'll be going up some of the bright stuff, lateraling over, and then up bright stuff again and steep.
I like that. And then, yeah, I like how that'll keep us in the lighter zone, because later on in the dive, I think Lizzie wants to confirm that as we get out of the white hard substrata, that there actually is mud just for ground truthing purposes. But I don't think we're going to get that far on this shift.
Mm-hmm.
I could be wrong, though. But yeah, I like that route. Thank you.
Sure.
Okay, so that was Rennie speaking. Do you guys want to introduce yourselves? I've got your names on the dive plan, but for the folks out there in
Sure, this is
video streaming land.
This is Renato Kane. I'm at the navigator seat.
Dan in the Herc seat.
This is Jake in the Argus chair.
And Stephen Matter in the video chair.
And Taylor Ann in the data logger chair.
And this is Di Waters. I'm with the National Marine Fisheries Service in the lab in Santa Cruz. And I work in the groundfish group on habitats. And we've been doing these, oh, here's the crew, a shot of the crew right here on channel 3.
Which camera are we looking
that are
at?
on the ship Nautilus.
One. Right above your head.
That one? I don't know the numbers of them.
Sorry, I was trying to point for you guys, but I should have just said.
Hi, Taylor Ann. Was that you like waving? Hi, guys.
Hi.
If you go to channel 3, you can see that shot of the crew in the control central. And are you in the van on the ship, or where exactly are you on the ship?
Yep, we're on the top of the ship in the control van, which is 3
Control van.
shipping containers married together.
Wow. And I am sitting at my dining table at home in Mountain View, California. And Lisa, who will be joining us shortly, lives in Aptos and will be joining us from her home. Most of the scientists participating in this cruise are doing so from home, primarily because of the COVID situation. But the Nautilus operation, or the Ocean Exploration Trust operation, includes a science chat in which scientists from shore can participate via a chat room. But scientists that normally might be on the ship during this cruise are all from home due to COVID, and we're able to participate remotely via this telepresence technology that the Ocean Exploration Trust provides, which is pretty amazing. And someone in your group, I'm sure, can explain this better than I, how the video and audio signal are being transferred from the ship.
Is the like overhanging?
Yeah, so we have some designated satellite bandwidth. So all the videos and audio signals get beamed up to satellites from our ship and are sent to shore in Rhode Island at the Interspace Center. And from there, they go out across the world, back over the internet, to everybody at home. And channels 1, 2, and 3 that you see are all being fed from the ship. And channel 4, or the 4th feed in the quad view, is the map that comes from the Interspace Center. So it's all combined there, and then sent back out over nautiluslive.org or YouTube or whatever platform you're viewing on. And
Gotta return in sub bottom.
And yeah, we have satellite data coming to the ship this year via the V-Link, which is software being used by the scientists on shore so they can be on the same intercom system with us. And that's married with our audio here. And then, as I said, goes back out with the video via satellite to the ISC and then around the globe.
That's awesome.
Steve's being modest. There's basically a television broadcasting station built into the 3 consoles he's sitting in front of.
Yeah, there's a lot of different pieces of equipment that allow us to do all this. And
Wow.
yeah.
It's amazing.
Steve's definitely got the most buttons.
Got a lot of buttons.
He's got the what?
He's got the most buttons.
He wins.
I don't know what
Yeah, and it's working.
about
It's
90%
working
of them
very
do,
well.
but I like to go over there when he's not there and just push buttons at random.
Oh, so that's what's been going on over here.
What's this button do?
So on the channel 3, if you're watching, shows a map with the green oblong object is the ship, the Nautilus,